So I'm Lucas, and I wanted to talk about Gradle Android recipes. I work for Tooploox. It's a Poland-based software house. So big thanks for them for flying me here all the way from Poland. And so I wanted to talk about Android recipes because, I mean, we're Android developers, so we copy and paste a lot. I think Android is like top 5 tags on Stack Overflow. And we copy not only Java or Kotlin, but Gradle files as well. And I was guilty of that for 2 years. I was copying stuff without knowing like what's going on. And basically, Gradle was just a JSON file with configuration, whatever. So every time I try to do some modification of the build Gradle file by myself, or I see some nice trick and I wanted to modify it to my needs or improve on it, I would hit a wall because I wouldn't know exactly what's going on and how it works. And that's something I didn't like. And that's something I would like to see more, like trying to make the scripts better and not only using existing solutions. So that's why I wanted to talk about exactly what's going on with the things that we usually copy and paste. So this we'll just very briefly go over the basics because without knowing all the Groovy and Gradle basics, we won't understand anything of the Gradle scripts. So just briefly, syntax, pretty obvious. This is def is like a method. We don't usually write that in Gradle scripts. But the important thing is that the closure is defined by curly braces. Then if closure is the last parameter, then we can omit parentheses for it. And then if the method call is unambiguous, we can omit the parameters completely. And this is what we usually do. So what we could write like this with all the parentheses, we usually don't. We omit them and we get this nice DSL. So it's just important to remember that every time we see a closure and like a keyword or word and a closure, it's usually just a method call. So if we see a build script and a closure, then this is a method which has a closure passed. Then we have just a regular statement. Then we have another method that accepts yet another closure. Then we have a normal method without parameters, for which we do need to put parentheses always, because otherwise it would be ambiguous. Yet another method that accepts parameter, closure parameter, another one which accepts string parameter, and a normal Google method for which we need parentheses because there are no parameters. Next up, parameters. For example, apply plugin. What is plugin in this method call, apply? It's a parameter, but what is important is that Groovy doesn't really have named parameters, like in the language. It's just a syntactic sugar, so all the named parameters are actually being put into a map of string to object and passed as a first parameter to a method. So it's important because if you see apply method in a build script and you want to know which parameters you can pass, you actually only can rely on documentation to say apply method can accept this and these parameters. It's also important because sometimes you can pass multiple parameters, but only in certain combinations. So you need to remember that basically documentation is the way to go because you won't see anything in the method signature because it's just going to be a map. And then closures. So now here we have 2 classes that have the exact same method print text. What's important is there is no common interface. There's nothing that's binding those classes. These are 2 separate classes with no relationship whatsoever, except for the fact that they both have the same method accepting the same string, the string parameter. And when we create a closure, and closure is just like a Java, but with way more capabilities. So a closure is a block of code which can be executed. So what's so important about closures is that it can be executed in a different context that it's been written in. So whenever, if we want to execute this closure, it doesn't know anything about the printtext method. And only after we set a delegate for the closure, and delegate is something that is being used by Groovy language to see like on which object a method should be called if it's not declared in a closure. When we set this delegate and execute the closure, it uses the printtext from the delegate. So if we use writer1 delegate, it will use printtext from the first delegate, and if we use writer2, then it will use the delegate from writer2. And this is something that makes the Gradle scripts like the most difficult to read, because the delegate is very dynamic. So you also don't see in the documentation, or like in the documentation you see it, but you don't see it in the signature usually against what object it can be this closure can be executed. So in Gradle, if we set a delegate, then we say that this closure is executed against some object. So this print closure is first executed against writer1 and then against writer2. And closure is a Groovy concept. It's like a part of the language. And you can just use closure as a type. But there's also delegates too. This helps us understand in which context this closure is going to be executed. But Gradle adds something to this. It adds action interface. And this is just a SAM interface. So Gradle uses action to have a strongly typed information about against what object the closure will be executed. And anytime you have a closure or an action, you can always write closure in Groovy script because it will be coerced into action because Groovy does that. So this is important just because, for example, Gradle, in many places you have two methods with one that accepts closure and another one that accepts action. But for example, Android plugin only accepts action because they don't need to accept closure. It will work anyway. Okay, so just a word about executing Gradle scripts. This is a normal structure of a basic Android project. And we have build Gradle in the root directory, and then 3 projects, each one with its own build Gradle. And what will happen here is that we will get a project instance for every of the build Gradle files. And each one of those build Gradle files will be executed against its project instance. If you see apply plugin in a build script, then apply will be executed against a project. And if we look into the project source code, we'll see apply method that accepts a map. So each of the Gradle files will get its own project. And then the one that's in the root directory, it's just a special kind of project, which is a root project, which we can always refer to. It helps us, for example, talk between projects on the same level, like siblings, because we can always go through root project and find another one. Okay, so this is snippet from the root project's build Gradle file. And so now we know that build script is a method on a project. And we see in the documentation, this is actually a simplified signature, but it delegates to a script handler. So this whole closure passed to the build script will be executed against script handler. And that means that, for example, I missed something. Okay, so we have the The repositories is a method declared on the script handler. And because we know that okay, so this is executed against repository handler. So on the repository handler, we must have JCenter method, Maven method, and Google method. Okay, so this is a project. It has all the methods that we have. Another big thing, and it's in Gradle, are extensions. And every project, like lots of types in Gradle are extension aware. And whenever a type is extension aware, the instance of this type contains an extension container, which holds extensions, and each extension has a name and a type. And what's important for us is that whenever an extension aware, in this case project, contains an extension of some type, it gives us two additional things on the build, on the instance. We get a property with the name of the extension that returns it, and we get a method which accepts closure, which is then executed against this this extension object so that we can configure it. So, for example, when we apply Android plugin to our project, we will get an app extension added to our project with the name Android. And the app extension has all the methods that we know that we put in Android block, build types, product flavors, and so on. And so because we have this extension added, we get the method Android that accepts closure, and we get a property Android that returns the app extension that is added. And many objects in Gradle are extension aware, like tasks, containers, projects, basically not everything, but yeah. Okay, so for the first snippet, finally, we have naming APKs. Like we often want, for example, to add a version name to the APK, and we just Google how to add version name to the APK. We copy the snippet, probably change the replace. It's easy enough. But why it works? So in order to understand exactly what's going on here, we need to dive into yet another Gradle API, and these are domain object collections. So let's build them from the ground up. So first up, we have collection. And this is just a normal, regular Java collection that contains objects of type T. Then we have a domain object collection. And this is already a Gradle API, Gradle class. And domain object collection adds live notifications and filtering. And we'll see them just in a bit. Then we have named domain object collection, which obviously adds names. So each object is now identified by a unique name. We have named domain object set, and each new class extends the previous one. So named domain object set already has names, but now they are ordered. So the objects are ordered by their name. And finally, we have named domain object container, and actually this is the class we use the most, which also adds capability. It has capability to create objects. It knows how to create them. We have a simple person. Let's just use it as an example. It has a name, which is mandatory for objects that will be in the domain object collections, and a role, which is a string with a role. And then we can create a named domain object collection. This is actually a container, and we do this by calling the project container method, always. And then we can add people, and well, it's cool. What's important about these collections is that whenever we add a we add an object to the collection, we can access it with two new methods on this collection. So we can access the object with a property that has the name of the name of the object. And then we get a method with the name of the object that accepts a closure that configures the object that's inside. So if we add Amy and John, then now we can write container.amy and container.john, and we'll get their instances, or we can call methods on the, and we can also do that normally by calling just container.getByName or findByName, but we usually don't because we get this syntax, and why would we write more? So again, we have the container, we have two people, and now we can get Amy by just accessing the property called Amy, and this is because the person name is Amy, and then we can configure it like have a closure executed against instance by using the dynamically generated method on this container. Okay, next up we have on this named domain object collection we have listening features. So we can listen on whenever objects are added, removed. We can filter by name by matching some specification and all. And these three methods are important because they're so-called live collections. So if we say with type and a class, then the closure will get executed for each object of specified type, but not only for those objects that are already in the collection, but also for all subsequently added objects. And for all, it's a bit more obvious, but still, it's not like each that will get executed only for objects that are in the collection right now, but for all the objects that will ever be in the collection. So if we have, if we create the registry, register the listener, but notice that we used each, and each is Groovy method on the collection, and then add people, then we won't get the callback fired because we used each, and this only iterates through people in the collection right now. But if we use all, which is already the domain object collection API, now everyone will be printed out, even though they were added after adding the listener. Similarly, when object added is more verbose about that. When object added only works for objects that were added after registering the listener. So here we'll only get John printed because Amy was added before. And when objects removed will work exactly the same. And finally, we have the creating capabilities for named domain object container. And this is the reason why we usually don't write new whatever. Because the containers that we use usually already know how to create the objects that we want. So we can create an object, create and immediately configure it. We can maybe create it and only configure. So this people registry now knows how to create a person if it's not defined. And we can configure it and just add all the people, and then we can access those. And we didn't have to create new person manually. The container already knew how to do that. And we have lots of domain object collections on a project. We actually, I think, most often use task container. So when we write tasks.all, we will get all tasks and not only those that were added before we call the method. And on app extension, so the one that we get from Android plugin, we have product flavors, build type, signing configs, and more. Application variants, test variants, whatever. And so now this should get more clear that if we know that build types is a named domain object container, and the method, like the build types method accepts an action that's executed on the container that contains our build types, it's clear that release will configure the release build type, but if we write something that's not yet there, debug is already there, but we find like alpha or mock or whatever, then we'll get a new build type created and configured with the closure that we've passed. Okay, so back to the snippet. So this lengthy introduction was only here to know that if we call application variants.all, then we will get all the application variants that the Android plugin ever adds to the collection. Because this is the reason why we wouldn't be able to write this APK naming thing before the Android block or before like adding all the build types and flavors if we didn't have the all method. So we have the application variants. This is we get all the variants, and now for each of the variant, we just take its outputs, because every variant can have multiple outputs, because we can have multiple APKs defined for it, for example. And for each output, we will change the output file to use the original file's directory and original name, but with APK replaced with a version name.apk. And it is just an implicit parameter. We could write output and arrow and use output, or we can omit the parameter and use it instead. Right. So in Android Gradle plugin up to 3, so to point whatever you use, by default, if you include a library in your module, in your application module, then by default, the debug variant of the library is consumed. So even if you build a release version of your application, by default, debug flavor of your, data module will get consumed. In Android plugin 3.0, it changes. And now if you have a flavor and a build type for your application, then for all modules that you use, that you add to your application, the flavor and build type of the module will have to match the one from the application, one-to-one. So if you have application and data module, and your application depends on data module, and your application has alpha debug variant, then you will need to have alpha debug variant for your data module as well. So this probably will get annoying quickly to have like 5 Android modules and having to keep the build flavors and build types in sync. So knowing all this about the collections and how we can access objects in them, we can do that once. So we can have all of our Android projects in a list, app, data, MVP, whatever you use. We can define all the build types and flavors that we would like to use. And then for each Android project and for each of the build types, we can do project.android. We know we can do .android because this is an extension and we get a property for that. .build types or product flavors, and this is because we get a property in app extension for that. And then maybe create. And maybe create is named DomainObject Container API, which either creates an object with this name that we pass, or doesn't do nothing if such object already exists. So, because if we only used create, then the build would fail because debug and release build types are already created. So we can use maybe create to just skip those if they are already there. And this snippet will just configure everything. We won't have to write Android build types and all the things in the respective modules, but we can still do that if we want to configure them. It still works. Okay, next up, build config fields. This is also something like, you see, okay, I want to disable Crashlytics or whatever in my debug builds. How do I do that? Go to Stack Overflow, we see this. Okay, it's nice. We get a field in a build config class. Well, everything works. And then someone says, okay, but this is pretty annoying because you need to also keep the names in sync. You have lots of repetition. So let's do that. Let's extract all the constants and just call the methods with those constants, which is nice. I mean, it's better than the previous one, but it's still not perfect. So let's just, for completeness, let's see what's exactly going on. So build types is a method on an app extension, which accepts an action executed against container. We already know that. And this closure is executed against a build type because, again, name domain object container will add a method called release, which accepts a closure. So we have something that is executed against a build type. So this build config field is a method on a build type. What this means is that I should be able to write a method that will call the build config field on our build type and configure it for whatever we want. Is it debug, not debug, whatever. And if we have this method, then we can just call it. And now again, we know that Android property, because it's an extension, we can access it. We have build types. And because it's a name domain object collection, we have a property release that will return us the release build type. And this is something I haven't seen done I think, in other build scripts. This one still has a problem because if we want to configure a build type that's not yet added, so not a release or debug, we will fail because the property access only works if the build type is already there. So we still should write the configuration block for build types, because if we add a mock or whatever, then it will get created and then we can use it. But what should we then pass as a parameter? Because if you write this, it actually wouldn't work. Because if we're in a closure, then this is a class which contains the closure. So this, in the release closure, will be a project. It won't work. And this is why I mentioned delegates before, because now that we know that the block inside the closure that's passed to release, for example, will get executed against release build type, then we know that the delegate of this closure is build type, and we can access the delegate in Groovy by just using the delegate keyword. So now instead of writing this build config field 3 times for each of the build types, we do it once and then just call the method. So if we had 4, 10, 20 flavors, we can just configure whatever we want. Yeah. Okay, and finally, we have dependency resolutions. Like all the 2 most common, I think, dependency-related snippets. The first one irks me a lot because it's the only thing you can find in the documentation for Crashlytics. It's always done like this, and it doesn't make much sense. And the other one is just something I feel people, they add the Espresso contrib or whatever library, and it doesn't work because of the dependency resolution issues. And they exclude thousands of things until they finally hit the moment when their project compiles, and it's okay, let's leave it because we don't know what's going on actually. So first, let's see what's going on when how Gradle resolves dependencies. So let's say we depend on Rx binding, just normal one single library. And if we try to inspect dependencies for compile configuration, we can see that we depend on Rx binding, but also a bunch of other libraries. And why is that? This is because by default, Gradle resolves dependencies transitively. So if we depend on one library and this library depends on another library, then it will pull that dependencies as well. And if the other library depends on yet another, then we will go all the way until we have everything that we need to build the project. So having our app module, the resolved dependencies will include first Rx bindings 2.0 because we compile it explicitly, so we need that. But we will also depend on Rx Java 2.0.2, and this is because Rx binding depends on that. Then we'll depend on Rx Android 2.0 because Rx bindings depends on that. But then we'll also depend on Rx Java again because Rx Android requires that. But Rx Android requires Rx Java 2.0.0 and Rx bindings requires Rx Java 2.0.2. So we can see that Gradle says, okay, so we need a version 2.0.0 and 2.0.2. So let's take the most recent one. Let's take the most recent one. So we'll drop the 2.0.0 and just use 2.0.2. So we get the most recent versions usually when we do that. We can disable this behavior, change it, by saying transitive equals false. By default, it's always true. So if we disable transitive dependency resolution, then we'll only actually depend on Rx binding, and probably our project will crash if we don't manually explicitly require Rx Android and Rx Java as well. So let's just go over the syntax quickly, because the configuration name compile accepts some string, and it can have more than what we see. So we have group name and version. This is just Maven coordinates for whatever we want. It can optionally have a classifier. So for example, we can pull 310 backport library without the database, without the time zone database, by using classifier no t something something. And we can have an extension. And okay, just one thing before the extension. This is a method call that returns a configuration. And the closure that's after that is a method on a configuration. And this is something that was always confusing for me. Why, when we add the configuration block with transitive false, we need to add parentheses? And it's because there's no method compiled that accepts two parameters. There's one method compiled that accepts the string, and it creates an object which has a configure method that accepts the closure. So, so if we drop the parentheses, then it would be an ambiguous call, so we wouldn't know what's going on. So I mentioned the add extension option. So this is called an artifact-only notation. And if we say that we want a Rx binding AAR, this says I want only AAR artifact from this library. And libraries can have jar and AAR and whatever, like, I don't know, sources. They can define various artifacts. But if we say, I only want this artifact, we'll only get this. Usually we don't need that because most libraries ship only one artifact, AAR or jar or whatever. So it gets resolved automatically. But if we do say, I only want AAR, this is literally, I only want this library's AAR. So this implies that transitive is false now. And like, you only want AAR, you will only get AAR. And this is why I don't like this. Because we say at AAR, because we want the Crashlytics AAR, but then we also need to say transitive true, because even though we said that we only want AAR as a classifier, as a which artifact we want, we still want the transitive dependencies resolved. So we need to tell it explicitly because AAR disables that. And it doesn't make sense because Crashlytics only ships AAR. So we can just drop the AAR completely. It will get resolved to AAR properly, and we don't need the transitive explicitly set to true. Yeah. And I don't know why they don't. Why it would make sense if they had like jar and AR jar for Java libraries. I don't know. Okay, and then the exclusions. So what happens if we depend on Android test compile in Android test compile configuration on Espresso contrib? It depends on lots of other dependencies, and among them we can find recycler view, support annotations, and support v4, all with version 22.2.0. This is quite an old version at the moment. So, well, okay. What happens if we now compile also recycler view with version 25.3? So the versions differ here. And you know, if you remember what I said about the transitive dependency resolution and the versions, you would say, okay, then Gradle will say, let's use 25.3.1 because it's the most recent one. But it won't. It will fail because we have versions for app and desktop different. So what's going on? Why doesn't it just pull the most recent one? It's because like Gradle does resolve the versions only for a single configuration. So if we had compile old and new recycler view, then it will resolve to the most recent one. But Android test compile actually produces a separate APK. So it doesn't analyze the dependencies between two APKs because those are two artifacts, and it may just as well make sense to have different versions of recycler view in the test APK and in regular APK. It doesn't make sense though, and that's why the build fails, but this is Android plugin failing and not Gradle. So what we need to do in order to fix this is we need to find a way to have test APK contain also the same version of recycler view as our regular APK. And this is usually done by excluding dependencies from the contrib library. So here we get this Android test compile configuration with the Espresso contrib dependency. And we can configure it, and this is the same block where we would have transitive true or false. And we have this exclude method, which allows us to exclude just some transitive dependencies from resolution here. And this snippet is, I chose it because it doesn't make much sense either, because we exclude appcompat v7 and support v4 and recycler view v7. But this is, yeah. So this is just a list of dependencies. And now we see that there is no support libraries in here resolved for this. But yeah, we can just drop the specifics because we actually want to exclude all Android support dependencies. So this is one way to do that. The problem is that if we have, for example, another Android test compile library, which also depends on recycler view, then we need to yet again add the exclude block because it will pull the old version of recycler view again. So what we can do is explicitly request the proper version of recycler view and support library for Android test compile. And now, and this must be the same version as for compile. And now Gradle resolution will work because this is the same configuration, and it will choose the most recent one. It's also a bit more explicit as to what actually we want to force, which exactly version we want to force, but at some repetition we need to say, recycler view again, support view again, and whatever. Another way is we could disable transitive resolution completely, but then we would still need to add all the Android test compile dependencies for everything that Espresso depends on. So this doesn't make much sense. And we can do that also by just pulling the AR artifact because it will disable the transitiveness. And another popular way is to have force resolution, and this is for all configurations. We can have a strategy, like the exclude thing is what we do for a particular dependency, and resolution strategy is what we do for a whole configuration. So we can say that for all configurations, compile, Android test compile, unit test compile, whatever you have, if you see support annotations, you will use 25.3.1. And so even if you write, for example, different version in your compile method, then it will get forced to 25.3.1 anyway. And this is also nice because now you only write the version once, and you are guaranteed to have the same version for all the APKs that you produce. But then it's a bit separate from the dependencies block, so you need to know where to look if you want to find which version of support library you actually use. And that's it. That's it for now. So if you want to know more, I really recommend Groovy lang documentation because there are a lot of things that are not obvious. For example, the spread dot operator from the previous talk. And it's something that if you don't know that exists, then you don't know that you can use it. Also, the bit about closures, and because closure actually has owner and delegate and a this, and it's completely different. So it's nice to know. Gradle source code, it's really nice to be able to actually import it in Android Studio and read all the documentation and see which classes are implemented by which classes or whatever, and the source code for Android Gradle plugin as well, mostly because it's way more efficient to read actually documentation in IDE instead of just a decompiled code, for example, that we get in Android Studio if we command click or on stuff. And then what I recommend is to write a plugin yourself, because then you will have to understand, for example, extensions, how to add extension, how to work with extensions, and you will be able to just play with that. And there's Android snippets channel on Slack for the Gradle Summit. So if you have any question or want a discussion, I will hang out there. And if you want, this is my Medium and Twitter accounts. On Medium, I occasionally post about Gradle and Android as well. And Twitter is just Twitter. Yeah, and thank you.